What is up, 7th grade? This is lesson 24. Objective is, how do you reduce fractions? This is part 2. If you remember back in lesson 15, we did part 1, where we just worked with reducing fractions like this, where we thought real hard and we said, what factors are both, or what numbers are both a factor of 6 and of 8? And we said, oh look, 2 is both a factor of those. So what we did is we took the top and divided it by 2, and we took the bottom and divided it by 2, and we end up with this 3/4. And so we kind of just did that just by evaluation, by realizing, hey, 2 is a factor of both the top and the bottom. Well, today we're going to be working with a little bit larger numbers, like this 420 over 1050. And so initially I want to be like, well, those are really big numbers. I don't know what numbers are factors of both of them. And I could be there a while if I'm like, well, they're both factor of 2, they're both factor of 10. It can take a while. So what we're going to do is we're going to use what we call prime factorization. We've also done this as well. So we're first going to start off with that 420. And we're going to find all the prime factors of that. So first thing I see is it's 42 times 10. Neither of those are prime, so let's think. 42, I can say 2 times 21. 2 is a prime number, so I'll circle that. That 21 is going to be 3 times 7. Those happen to be both prime. And that 10 is 2 times 5. So for part A, it says use prime factorization to reduce. So I'm working on part A here. So the top is going to be 2 times 2 times 3 times 5 times 7. And I got these numbers 2, 2, 3, 5, 7 from right here. 2, 2, 3, 5, 7. I just wrote them in ascending order from smallest to largest. Now I'm going to do the same thing with that denominator, with the 1050. So I know 105 and 10. 105, I think 5 will go into that. 21 times 5 happens to be a prime number. 21 is 3 times 7. 10 is 2 times 5. So my denominator is going to be 2 times 3 times 5 times 5 times 7. So here I wrote both the top and the bottom as their prime factorizations. And so what I want to do is I want to reduce. So what I'm going to do is I'm going to look for numbers in both the top and the bottom. So here's a 2 and a 2. And I know 2 divided by 2 is just 1. Also here's a 3 and a 3. 3 and 3 divided by 3 is 1. And likewise here's a 5 and a 5. So this is going to come out to be on the top just 2 times 7. On the bottom I'm going to have 5. Oh, just kidding. I also have a 7 that will reduce. So what this is going to come out to be, because 7 divided by 7 is 1. So on the top I just have a 2, on the bottom I just have a 5. So this huge big number reduces down to 2/5. So that's part A. For part B, it says find the greatest, that means the biggest one. Common means that they both have factor. So it means I can multiply a number by it to get that number of my numerator, my denominator, my 420. And my 1050. So what I need to do is I need to find all of them that I have in common. Well, I just found all of them that they have in common. So the greatest common factor here for part B is going to be that 2, because notice I reduced the 2 and the 2 right here, times 3, 3 and 3 there, times 5, there's a 5 in both of them there, and a 7 in both of them here. So I'm just going to try to make this easy. 2 times 5 is 10. 3 times 7 is 21, and 10 times 21 is going to be 210. So that's going to be the GCF, the greatest common factor of 420 and 1050. So now, where this reducing fractions really comes in handy is whenever we're working with multiplying different fractions together. So this is example 3. There's two different ways to solve this. I could just say 9 times 2, 18, 16 times 3, some big number, and then find factors of the top and the bottom and try to reduce them like we just did. But there's actually an easier way to do that. I recognize that this 9 and this 3 have a number in common, and that number is 3. So what we're going to do what we call reducing. So I know that 3 will fit into 3 so one time. So instead of the 3, I'm going to write a 1. And I know that that same number will fit into 9 3 times, because 3 times 3 is 9. I'm going to do something similar with these other two because I realize that these are both an even number and that 2 will fit into both of them. So I know 2 will fit into 2 one time, or 2 divided by 2 is 1, and that 16 divided by 2 is 8, or 2 will fit into 16 8 times. So what I've just done is I've changed this fraction up here, that 9/16 times 2/3, into this, 3/8 times 1 over 1. Well, that's pretty simple because I know I multiply the top 3 times 1, that just gives me 3, and the bottom's 8 times 1, that gives me 8. So my answer is 3/8. Now I can do the same thing even whenever I have multiple numbers multiplying, like here in example 4. So let's start off and see if there's anything I can reduce from top and bottom. Well, initially I see the 3 and the 9, kind of like I did over here in example 3. So 3 goes into that 3 one time, or 3 divided by 3 is 1. 9 divided by 3 is 3. And I see the 5 and the 10. That's not too bad. 5 divided by 5 is 1. 10 divided by 5 is 2. And then even though they aren't next to each other, that everything's multiplying, I see the 4 and the 8. So 4 divided by 4 is 1. And 8 divided by 4 is 2. So now I've changed my numerator. So my first fraction there, instead of being 8 over 9, is now 2/3. My second one, instead of being 3 over 10, is now 1/2. 1/2. And instead of being 5/4 is 1 over 1. So I just need to multiply all three of these. 2 times 1 times 1 gives me 2 on the top. 3 times 2 times 1 is going to give me 6 on the denominator. However, dun dun dun, I missed something. So we notice that there's a 2 here and a 2 here. Those would actually reduce as well. So let me go ahead and say, 2 goes into that 2 one time, and 2 goes into that 2 one time. So instead of this, I have 1 times 1 times 1 on the top, which is just 1. On the bottom I have 3 times 1 times 1, which comes out to be 3. So it came down to be 1/3. Now if you made the mistake like I did, and just gotten 2/6, that's fine. Just recognize, hey look, those are both even. So I can divide the top by 2, like we did back in lesson 15, and divide the bottom by 2, and gotten 1/3. And that obviously still see you would have gotten the same answer. So either way, you'll be okay. Your homework is there on page 172 is where it starts. You're going to do all of the practice set problems. Yes, that's right. I said the practice set problems. Those are labeled like A, B, C, D, E, etc. You can do all of them from lesson 24, all of them from lesson 23, and then 9 more of your choice.